Guys, this lesson will be covering functions and function notation. So what's a function? A function has the following three characteristics that we will explore today. The first one is that it has a specific x value that it takes in, and it outputs one y value. And therefore, it passes the vertical line test, and it is also denoted by the function notation of f bracket x, or you can say f of x. I like to imagine it as a box. In this box, it's a relation. Let's say I choose x squared minus 9 as the relation inside this box, this function box. So this function, it takes in an x value and it outputs one specific y value, like this, right? This is visually how it works. An x value comes in and it goes through a series of transformations, and then a y value is outputted. Let's say our x is 3. Then, following this transformation, our y value is going to be 0. That's how a function works, right? But a very important thing is that x equals 3, right? Or x input can only generate one y output. That's the key thing. An x value can only output one distinct y value. X equals 3 cannot output y equals 10 or like 11. Only 0. That is your key thing that you have to remember about functions. Another thing is that although your x can only generate one y, a y equals 0, it could be generated using many different x's, or y equals 10 or y equals 11 or whatever. A function of, again, your y value can be generated using different x values. For example, y equals 0 could be done using x equals 3 or x equals negative 3, right? So your one value restriction only applies to your x, and does. Let's go through the vertical line test. A vertical line test is essentially when you have a graph of a relation, like the blue one here, that's a graph of a relation, and you have a vertical line drawn. What we want to get here is that if this vertical line that you drew that cuts through the graph in any way, if that vertical line cuts through the graph, intersects with the graph more than once, then it is not a function. But if the vertical line only intersects once with the graph, then it is a function. Because as we go back to the idea earlier, an x value can only generate one y value. So here, same thing here. If looking at this function here, right? As you go this way or this way, you don't see any x value repeating. You have 2, 7.3, and then you have another point. Let's say that's like negative 5, 0.1, right? These two are different x values, and they output different y values. It's nothing like, I don't know, 2, 0, and 2, 0 and 2, 1. This does not happen anywhere like this in the function, because that will not pass the vertical line test. It only passes the vertical line test if it's a function. Just know that, okay? Let's say you don't have a function. Let's say you have like a circle. That's not a function, right? Circle. And you draw a vertical line through it. Draw a vertical line through it. Boom. It doesn't pass because it intersects with the vertical line twice. Not a function. Why? Because if a circle, it allows a circle relation. It allows things like 2 to 0 and like 2, 1, because these two x values, these x values 2 and 2, they're the same x value, but they output two different y values. Therefore, it's not a function. And if you were to plot it on here, that happens. The vertical line crosses through twice, which obviously again signifies that this relation is not a function. Okay, so let's test if it's a function or not. These are some practice problems. First of all, let's see this. Student Craig, Amanda, Stephanie, and Amit. Practice day, Saturday, Thursday, Tuesday. Is this function or not? Okay. Again, theorem of a function. One x value outputs one y value. Done. Right? One specific x value only produces one y value. Craig goes to Tuesday. Boom. Good. Magda goes to Tuesday. Good. Stephanie goes to Thursday. And Amit goes to Saturday. Yeah, that's a function. Because Craig, right? Craig, he doesn't go to Saturday and Tuesday. He only goes to one, which is Tuesday. This is the y. This is the x. X only gets one x produces one y. Boom, done. Right? This one is not a function because your age, so your x value, age, y value, practice day, your age goes to both Thursday and Tuesday. One x produces two different y's. Therefore, it's not a function. Because 16 to Tuesday, okay. 17 to Saturday, okay. But 15 goes to both Tuesday and Thursday. That's not a function. Let's test it out. Now for a graph like this. Now we use the vertical line test. Literally draw a vertical line down. It only intersects with the graph once. Therefore, it is a function. For a circle, let's try it. Vertical line through the graph. It does not intersect once. It actually intersects twice. One here, one here. Therefore, it's not a function. All right. Function notation. So a function is, again, denoted by f of x. And if we have f of 2, for example, and your f of x equals 2x, so normally your exam will give you f of x is 2x. And it asks you to find, let's say, f of 2. What you do is just simply plug in this 2 for x. Whatever is in this bracket, you plug it as x. So f of 2 is 2 times 2 is 4. Okay, let's do some examples. Okay, onto our first question. If g of x is x squared minus 4x, find g of 10 over 5. Okay, let's first understand what's g of 10. Again, it doesn't have to be f, right? It could be h of x, or g of x, or I don't know, t of x, right? This front number does not matter. As long as it has a bracket and x, that's a function, right? So g of x is a function defined like that. So again, we plug in whatever x is, whatever it is in the bracket as x, okay? So in the bracket, it says 10. So you plug in 10. 10 squared minus 4 times 10, 16. All right. And you have 5 there. So g of 10 over 5 equals 60 over 5. All right. Which obviously gives you 12. All right. That's your... Okay. So this question asks you, given this graph on the left side, find the value of x such that f of x equals 3. So what this means is that at what x value, what input gives you a y value of 3? Because remember, f of x stands the same thing as y. It's the same meaning. For example, f of x equals x squared. Same thing as y equals x squared. So it's basically saying that when y is 3, what x value comes in that plugs, what x value do you plug in to get 3? So basically you go into your graph and you draw y equals 3. So when is the graph at y equals 3? Obviously it's at 3. So when x equals 3, y equals 3 as well, from your input and output, right? Therefore, x equals 3. Okay, because at because when this at what x value is y equals 3? At 3 as x outputs y equals 3. Okay, let's try this a bit more advanced question. Given that f of x equals 3x plus 1 and g of x equals 2x plus 3, determine the values of a such that f of a plus 1 equals g of a. So again, let's first break down. What's f a plus 1 first? Okay, before we do that, let's just examine the question. What's this saying? It's saying that what a value satisfies f a plus 1 equals g of a, right? So basically, we're just finding the expression for f of a plus 1 and the expression for g of a, and then just setting them equal to each other, okay? All right, so let's find f of a plus 1 first. Same thing here. Whatever is in the bracket, you plug it in as x. Boom. Like f of x, it could be f of a. Same thing, right? What you're given is your function. You plug in the variable as the bracket, right? So your bracket is a plus 1. Plug in as x. So there you go. Expand it and collect like terms. Okay. Now g of a is going to be, again, plug in the bracket as x of g. There you go. So now we just set them equal to each other and solve for a. And then you get a, right? Move this over, you get -1 is a. Okay. Yeah, so that's basically function notation and what is a function for you guys. I hope you guys enjoyed the video, and please follow us and leave us, a review.